Chapter 3, Section 6 is all about compound inequalities, and it is a two-part lesson, so by the end of part 2, you should be able to write an inequality to model a real-life situation and solve linear inequalities. Okay, to get started, we're just going to look at this one that actually uses a compound inequality to show you what we mean. Okay, so the diagram at the right shows the number of boxes of oranges that an orange tree could produce in 1 year. An orange grower earns $9.50 for each box of oranges that he sells. How much could the grower expect to earn in 1 year from one tree? All right, well, if you look at our graph over here, there's two different numbers and it's colored in between because not every orange tree is the same and they may not all produce exactly the same amount. But what this is saying is that the smallest number of oranges that would be produced would be 1.3 boxes and the largest number would be 4 boxes, with anything in between. Okay, so to figure out how much this grower could expect to earn, we're going to multiply 950 times 1.3 and find out that he could earn as little as $12.35 from this one tree, or if we did 950 times 4, he could earn as much as $38 or anything in between, anywhere from $12.35 to $38. So what an inequality that is compound or has multiple possibilities with ends, places that it ends on either side, means I'm going to take the amount that could be earned, and that has to be bigger than or equal to $12.35, but it would be less than or equal to 38. So because it's both, you can write it as one inequality with two different possibilities, and that's a compound inequality. Leading me to my vocab, which is the definition of compound inequality, much like the definition of a compound word, where I take two words that are single and I put them together to form one. In math, we have two inequalities that are joined together by either the word and or the word or. Okay, if your compound inequality has the word and, that means that my two individual inequalities would have some overlap. So the graph of x is greater than or equal to 3 looks like this red one. The graph of x is less than or equal to 7 looks like this blue one. And if you notice, they actually have a large area where both of these graphs cover the same amount. So that's called your overlap, and that would be your compound inequality. Right here, this section of overlap covers both of those requirements. So that is your compound inequality. And with the word and, you could also write it as x is greater than or equal to 3, but less than or equal to 7. Now, if your compound inequality has the word or, that means that my two graphs, so x is less than -2, and x is greater than or equal to, those actually have no overlap. This whole section, there's nothing. So in an or compound inequality, that means they can have one or the other, and when they're on a number line, when they're graphed on a number line, they're actually going to be in two different places facing separate directions. All right, so we're going to use that information to write and graph the compound inequality that they give us. They're going to write it as a word sentence. We are going to turn it into a number sentence that is a compound inequality. Okay, so all real numbers that are greater than -2 and less than 6. Okay, we know because of this and that they're going to have overlap, so we're going to be able to write it all out as one sentence. And this all real numbers, that's just in place of whichever variable you're going to use. I'm going to use x. So my x's are greater than -2 and less than 6. Okay, because of the and, I should just need this one. Make that greater than -2, but less than 6. Okay, all real numbers that are less than 0 or greater than or equal to 5. Okay, because of this or, I know that I'm going to need two inequalities. And I need my first one to be less than 0. And I need my second one to be greater than or equal to 5. Now they also asked us to graph these. So I'm going to go back up to this top one. I need to be able to fit from -2 all the way to 6. Just barely. Okay, they're both open circles because neither one of them have the equal to bar. So I need an open circle at -2, and my x's are larger than that, so it would face this direction. My next open circle is at 6, and my x's are less than that, so it would face this direction. And we only care about what's in between here because it has to meet both criteria. All right, on the bottom here, I'm going to need one graph with 2 separate things on it. So I have to be able to go at least 0 to 5. I should probably try to squeeze in a 6. Okay, my first one, open circle at 0, and my x's are less than that. Second one, closed circle at 5, and my x's are greater than that. All right, why don't you try these? Pause the video here, try these out, and come back to check your answers. All right, welcome back. All real numbers that are greater than -4 and less than 7 looks like this. With an open circle at -4 going this direction to our open circle at 7, which is going this direction. All real numbers that are less than or equal to 2.5 or greater than 6. Okay, closed circle at 2.5 right here. Less than. Open circle at 6, greater than. Explain the difference between x's between -5 and 7 and x's between -5 and 7 inclusive. Okay, so x's between -5 and 7 just means that it's actually in between -5 and 7. It doesn't, my goodness, sorry. It does not include -5 or 7. It's numbers in between those. But when they add the word inclusive, that now means that it could be -5. And it also could be 7 or anything in between. So this is open circles or greater than, less than. This is closed circles because they would have the equal to bar. Solve and graph -3 is less than or equal to m-4, which is less than -1. Okay, we now have a compound inequality that actually needs solving because we need this m to be by itself, and there's a couple different ways that you can do that. The first thing you can do is you can actually split it up into 2 separate inequalities. Okay, that one would require this to be our first. Okay, we need everything in the middle with one of the sides. So I have -3 is less than or equal to m-4. And then the second equation that I would need to solve is this part. Okay, so m-4 is less than -1. All right, when I go to solve these, I'm just going to add 4 to get the m by itself, and m is less than 3. And then add 4 and 1 is less than or equal to m. Those are the answers to our inequality. The second method is actually just to do the whole thing at once. Okay, so I write down -3 is less than or equal to m minus 4, which is less than -1. And I do the exact same thing that I've been doing all along, only instead of having one train track, I actually have 2 sets. And whatever I do to one side, I have to do to all 3 parts. So to get this m by itself, I have to add 4 to all 3 parts. Okay, -3 plus 4 is 1, which is less than or equal to m, which is less than 3. So I have right here, I should have the same thing on both sides. 1 is less than or equal to m, and m is less than 3. All in one compound inequality. You're welcome to do it either way that you like. You may find that the second way is a little bit faster. Okay, try that. Right here would be a good place to pause. Come back when you're finished. See if you have the same answers as I do. Okay, this one's actually a 2-step in the middle. I still went with the all-in-one method, but -2 plus 4 is 2, which still leaves me with a 3y. Okay, then I, just like normal, I'm going to divide by 3 on all 3 sections. Okay, now if you get a fraction, leave it as a fraction, like this 2/3. So my answer will be 2/3 is less than y, which is less than 6. Okay, on the bottom, I'm going to subtract 2 in all 3 places. And I'm going to get -4 is less than x, which is less than or equal to 3. All right, that ends part 1 and the homework that you should be able to do tonight.